Haomin Photonics has recently launched a 780 nanometers repetition rate locked femtosecond optical frequency comb. The system is housed in a standard 2U rack mount chassis, allowing direct installation into standard equipment racks. For convenient deployment and integration, the front panel features a clean and intuitive layout. On the left is the free space optical output port, followed by a monitoring optical output port that provides 1560 nanometers fundamental light output. Next are the reference signal input, RF monitoring port, a reserved interface, and the communication interface. The power switch is located on the far right side of the panel. Next, let's take a look at the system integration and overall performance. The frequency comb is equipped with a dedicated computer terminal for system control and monitoring. At the top of the interface, the lock status of the control board is displayed. Locking can be achieved through simple switch operations, with clear lock indicators providing real-time feedback. Below this section, the seed pump current is displayed, which directly corresponds to the pump power. Further down are the pump currents for the 780 nanometers output, and the corresponding monitored pump power. Most of the key power-related parameters are conveniently displayed in this area. At the bottom of the interface is the mode locking status monitor. Under normal operation, the indicator remains green, while any abnormal condition will cause it to turn red. In practice, the mode locking state is highly stable, and the indicator remains green for virtually all operating periods. For the output power measurement, a Thorlabs S1-4C photodetector was used, covering a wavelength range of 350 nanometers to 1100 nm. After setting the detector wavelength to 780 nanometers, the measured output power was 104 megawatts. The power fluctuation was extremely low, at only about 0.01 megawatt. Such minimal power variation demonstrates the excellent stability of the internal optical amplification system. The monitoring port provides the spectrum of the fundamental light. The spectral shape and power can be adjusted via the front panel monitor pump, which supports up to 800 milliamperes and nearly 100 megawatts output power. Here, the input power is below 10 megawatts, resulting in a relatively narrow 3 dB bandwidth. Next, let's examine the RF signal. A 1 GHz photodetector was used for the measurement. The RF spectrum remains remarkably flat up to 1 GHz, while strong signal components are still detectable beyond 1 GHz. After further amplification, an exceptionally high signal-to-noise ratio is obtained, demonstrating that the frequency comb provides an ultra-low noise seed source. After measuring the RF side mode suppression ratio, a frequency counter was used for further evaluation, with a 1-second gate time and frequency division enabled. The measured frequency deviation remained at the sub-millihertz level, typically only a few hundred microhertz. This confirms the excellent stability and low drift of the locking system. A simple vibration test was also conducted. Normal speech and light tapping had no impact on the lock, demonstrating the system's strong robustness and stable operation. This 780 nanometers repetition rate locked femtosecond frequency comb is ideal for free space optical applications, requiring ultra-low frequency and timing jitter. With up to 100 megawatts output power, it is well suited for precision metrology, quantum optics, cold atom research, and 2-photon microscopy.